Namaste dosto. Today, we are going to explore an exciting topic from vector algebra, the addition of vectors. Imagine you are giving directions to a friend. First, walk straight ahead, then turn right. Vector addition is the magic that combines all these movements into one straight path. Now, vector addition means combining two or more vectors to get a single vector called the resultant or sum vector. Here's something very cool. Vector addition follows the commutative law. That means if you add vector A to vector B, it's just the same as adding vector B to vector A. In math language, we write this as vector A plus vector B equals vector B plus vector A. The order does not matter at all. Geometrically, you can see this by using either the triangle law or the parallelogram law. These methods show how vectors add up visually. The key takeaway here is that the resultant vector you get is independent of the order in which you add the vectors. So, whether you add a then B or B then a, the final result stays the same. Think of it like planning your route from home to school. The path might look different, but the total distance covered remains constant as long as you follow the rules. To help you see this clearly, imagine a triangle where one side is vector A, the next side is vector B, and the third side, taken in the opposite direction, is the resultant vector. This triangle visually proves the commutative property and the concept of vector addition. Excellent. Now you have the foundation to explore the geometric world of vectors. Let's dive deeper into one of the most important methods to add vectors, the triangle law. Imagine you have two vectors, vector A and vector B. Place vector B as tail exactly at vector A's head. That means you put them head to tail. When arranged this way, their sum or resultant vector is represented by the third side of the triangle, but taken in the opposite order, from the tail of vector A all the way to the head of vector B. In simple words, if vector A and vector B are two sides of a triangle taken one after the other, their sum is represented by the final side of the triangle facing the opposite direction. Mathematically, we can write this as vector R equals vector A plus vector B. Repeat with me, vector R equals vector A plus vector B. This works perfectly for any two vectors acting from a point at the same time. Try imagining this. If you walk a certain distance east, then turn and walk north, your total displacement is the diagonal of this triangle. That diagonal is your resultant vector. This triangle law helps us visualize how vectors combine step by step, making vector addition easy and intuitive. Shabash, we are moving wonderfully. Next, let's learn another fascinating way to add vectors, the parallelogram law. Suppose you place two vectors, vector A and vector B. So they both start from the same point and form two adjacent sides of a parallelogram. Now, when you complete the parallelogram, the diagonal that starts from their common point gives you the resultant vector, vector R. In formula words, vector R equals vector A plus vector B. Let's say that slowly. Vector R is the sum of vector A and vector B. This method is very useful when both vectors originate from the same point, making it easy to compare them directly. One important thing to notice here is the direction of vector R. It always lies somewhere between vector A and vector B, depending on the angle between them. Its magnitude also changes based on how wide or narrow this angle is. Now, let's shift from geometry to numbers, because sometimes calculations need more precision. When vectors are given in Cartesian form, such as vector A equals A1 times I hat plus A2 times J hat plus A3 times K hat, we can add them component-wise. What does that mean? Well, if vector B is given similarly as B1 I hat plus B2 J hat plus B3 K hat, then the resultant vector R is the sum of the corresponding components. So, vector R equals open bracket A1 plus B1 close bracket times I hat, plus open bracket A2 plus B2 close bracket times J hat, plus open bracket A3 plus B3 close bracket times K hat. Let me say it again slowly. Vector R equals open bracket A1 plus B1 close bracket I hat plus open bracket A2 plus B2 close bracket J hat plus open bracket A3 plus B3 close bracket K hat. This analytical method makes solving vector problems straightforward, especially when dealing with three-dimensional space, like vectors flying around in physics or engineering problems. Imagine drawing the x, y, and z axes and plotting each vector by its components. Adding vectors is then like adding the lengths along each axis, and that gives you the resultant vectors components. Easy and very powerful. Superb. Component-wise addition is your new best friend for vector calculations. Let's try a solved example to see how all this works in practice. Suppose vector A is 3i hat plus 4j hat, and vector B is 1i hat plus 2j hat. Find the resultant vector R, which is a plus B. First step, add the x components. Our subscript x equals 3 plus 1, which is 4. Next, add the y components. Our subscript y equals 4 plus 2, which is 6. Therefore, vector R equals 4i hat plus 6j hat. Now, what about the magnitude of this resultant vector R? Use the formula for magnitude, square root of our subscript x squared plus our subscript y squared. Calculate square root of 4 squared plus 6 squared, that is square root of 16 plus 36, which equals square root of 52. We can simplify that to 2 times square root of 13. So, the magnitude of R is 2 root 13. To find the direction, theta, measure the angle vector R makes with the x-axis. Theta equals tan inverse of our subscript y divided by our subscript x. Here, that's tan inverse of 6 divided by 4, or tan inverse of 1.5. Pause a moment to imagine or calculate this angle, which gives you the exact direction of the resultant vector. This example shows clearly how component-wise addition and triangle law combine beautifully. Well done, Beta. Now that you know how to add vectors, let's understand some essential properties. The algebraic laws that govern vector addition. First, the commutative law tells us vector A plus vector B equals vector B plus vector A. So, changing the order doesn't change the result. Next is the associative law. The way we group vectors doesn't matter. Whether you add A and B first, then add C, or add B and C first, then add A, the final vector stays the same. Formally, open bracket A plus B close bracket plus C equals A plus open bracket B plus C close bracket. There's also the zero vector or additive identity. Adding a zero vector to any vector leaves it unchanged. So, vector A plus vector 0 equals vector A. Finally, each vector has an additive inverse. Meaning if you add vector A and its negative vector minus A, the sum is the zero vector. So, vector A plus minus vector A equals zero vector. Imagine these properties as the rules that keep vector addition consistent and reliable. Just like rules in cricket or traffic, without them, things would get confusing. These laws also allow us to manage vectors easily in more complex problems. Shabash. Let's quickly recap what we learned today on addition of vectors. First, the key formula. Vector R equals vector A plus vector B. This applies when using geometric methods like the triangle law and parallelogram law. Second, the analytical formula for Cartesian coordinates. Vector R equals open bracket A1 plus B1 close bracket I hat plus open bracket A2 plus B2 close bracket J hat plus open bracket A3 plus B3 close bracket K hat. Third, the magnitude of the resultant vector is the square root of the sum of the squares of its components. Square root of our subscript x squared plus our subscript y squared plus our subscript z squared. Remember the key ideas. Vector addition obeys the commutative and associative laws, so order and grouping do not change the result. Geometrical methods, like the triangle and parallelogram laws, help us visualize vector sums. Component-wise addition simplifies calculations in both 2 and 3 dimensions. Lastly, every vector has an additive inverse, and the zero vector acts like the identity element in addition. Keep practicing these concepts because understanding vector addition will help you in physics, engineering, and even in daily logical thinking. Soch ke dekho, every step you take in adding vectors is a step towards mastering complex scientific ideas. Shabash, you did great today. Keep it up.